Hello, space explorers! Today we are going on an amazing trip. We will travel to one of the strangest places in the whole universe. We are going to a black hole. What are black holes, you ask? Imagine something super heavy. So heavy that its pull, its gravity is stronger than anything else. This pull is so strong that nothing, not even light, can run away from it. That is what a black hole is. It is a place in space where gravity wins every single time. It is like the ultimate cosmic vacuum cleaner, sucking everything nearby into its mysterious depths. How do these incredible things get made? Well, they often start from giant stars. Think of stars much bigger than our own sun. When these huge stars get very old, they run out of fuel. They cannot shine anymore. Then a big thing happens. The star falls in on itself. It collapses under its own immense weight. Boom! Sometimes this makes a huge explosion called a supernova. What is left behind can be a black hole. All the stuff from that giant star gets squeezed into a tiny space. This makes the gravity super strong. Are you ready to imagine a journey to one? Let's get started on our mind-blowing adventure to the heart of a black hole. Imagine you are in a super strong spaceship. You are flying towards a black hole. From far away, it does not look like much. Maybe you see stars around it. Maybe you see gas swirling, getting hotter and brighter as it gets closer to the black hole. But the black hole itself is just a spot of perfect blackness. As you get closer, your spaceship's computers will tell you that the gravity is getting stronger. But you might not feel anything different just yet. Space is big, and the changes happen slowly at first. The most important part of a black hole from the outside is something called the event horizon. Think of it like an invisible line or a bubble around the black hole. This is the point of no return. If you cross this line, you cannot go back. Ever. The gravity beyond the event horizon is so strong that you would need to travel faster than light to escape. And we know that nothing can travel faster than light. As you get closer and closer to the black hole, even before you reach the event horizon, things start to look very weird. The black hole's powerful gravity does not just pull on objects, it also bends light. Imagine light as a stream of tiny balls. When these balls pass near something very heavy, their path gets curved. A black hole is super heavy, so it curves light a lot. This means your view of the universe outside will get very distorted and strange. It is like looking through a very powerful, very weird lens. You might see some very cool and very confusing things. The stars behind the black hole might look like they are in a ring around it. This is called gravitational lensing. Now, let's talk about what you would feel. The gravity of a black hole is incredibly strong, but it is also very particular. It is not just about being pulled in, it is about how you are being pulled in. The force of gravity gets weaker with distance. So if you are falling feet first towards a black hole, the gravity pulling on your feet will be much stronger than the gravity pulling on your head. This difference in gravitational force is called a tidal force. These tidal forces are what would cause a very strange effect. Your body would start to stretch. Imagine you are a piece of dough. If you pull one end harder than the other, the dough stretches out. The black hole does the same thing to you. Your feet are pulled much more strongly than your head, so you get stretched longer and longer. At the same time, the sides of your body would be squeezed inwards. This is because all parts of you are being pulled towards the single tiny point at the center of the black hole. Section 5. Time plays tricks, your clock slows down. One of the most mind-bending things about black holes and strong gravity is what happens to time. According to Albert Einstein's theories, gravity can affect time. Stronger gravity makes time pass more slowly. This is not science fiction, it is real physics. We have even measured this effect here on Earth, though it is very tiny. Clocks at sea level run a tiny bit slower than clocks on a high mountain, because gravity is slightly stronger at sea level. Near a black hole, this effect becomes huge. So, as you fall towards the black hole, time for you would start to slow down compared to time for someone far away. Let's say you have a friend watching you from a spaceship very far from the black hole. They have a clock, and you have a clock. As you get deeper into the black hole's gravity, your clock would tick slower and slower compared to your friend's clock. If you could look at your friend's clock, you would see it ticking incredibly fast, showing their future rushing by. For you, falling into the black hole, time would feel normal. Section 6. Frozen in time, how others see you fall. Now let's flip the perspective. What would your friend, watching from their distant spaceship, see as you fall into the black hole? It is a very different picture. Because your time is slowing down relative to theirs, they would see your journey happen in extreme slow motion. As you approach the event horizon, they would see you moving slower and slower and slower. It would be like watching a video that is being played back at an almost infinitely slow speed. As you get extremely close to the event horizon, the light coming from you would also be affected. The strong gravity would stretch the light waves, making them redder. This is called gravitational redshift. So, your friend would see your image become redder and dimmer, and you would appear to move more and more slowly. Section 7. Past the point of no return, inside the darkness. Once you cross the event horizon, you are truly in a new realm. There is no turning back. No matter how powerful your spaceship engines are, you cannot escape. The gravity is too strong. Inside the event horizon, space itself is flowing inwards, towards the center, faster than light. It is like being on a conveyor belt that is moving too fast to run against. You, your spaceship, and even light itself are all carried inevitably towards the black hole's core. What would it look like inside? This is where things get even more speculative because no one has ever been inside a black hole and come back to tell us. But based on our theories, it would be a very strange place. The view of the outside universe would be severely distorted. As you fall deeper, the light from the universe behind you would get concentrated into a smaller and smaller patch of sky. Eventually, this patch might look like a bright, tiny window, showing the entire history of the universe speeding by due to extreme time dilation. Looking forward, towards the center of the black hole, you would not see anything shining. The singularity, the very heart of the black hole, does not emit light. Section 8. The heart of the monster. What is the singularity? At the very center of a black hole, our current theories predict something called a singularity. What is this strange thing? Imagine taking all the stuff that made the black hole, all the mass of that giant collapsed star, or maybe even millions of stars, and squashing it down, and down, and down, until it takes up no space at all. A point of zero volume but with enormous mass. That is a singularity. It is a place where density becomes infinite. This idea of a point with infinite density is a big problem for physicists. Infinite is usually a sign that our theories are incomplete. It means the math we use to describe gravity, Einstein's theory of general relativity, breaks down at the singularity. Section 9. Beyond our understanding, the cosmic enigma. Our journey to the heart of a black hole has been a wild ride, hasn't it? We have seen light bend in strange ways, felt gravity stretch us like spaghetti, and watched time itself play tricks. We have crossed the point of no return, and headed towards the ultimate unknown, the singularity. Black holes are truly one of the universe's most extreme and fascinating creations. They push our understanding of physics to its very limits and beyond, showing us that the cosmos is even weirder and more wonderful than we can imagine. What happens at the singularity is still a huge mystery. Our best theories, like Einstein's general relativity, tell us it is a point of infinite density, but that is likely where our current physics breaks down. We need something new, a theory of quantum gravity, to really understand what goes on in such an extreme place. Scientists around the world are working hard on this problem. Every new discovery about black holes gives us more clues, helping us piece together this cosmic puzzle. It is a quest for knowledge that drives us forward. Black holes also teach us about the life cycle of stars and the evolution of galaxies. Supermassive black holes, millions or even billions of times the mass of our sun, sit at the centers of most big galaxies, including our own Milky Way. How did they get so big? How do they affect the stars and gas around them? These are active areas of research. By studying black holes, we learn not just about these strange objects themselves, but about the entire universe and how it works on the grandest scales.